Hello everyone, so today we are going to do Leetcode daily challenge, create largest element in an array. So earlier also we had did some question which was create largest element in a stream. There although we were having elements which were coming one by one, so we were required to keep track of each and every element. But here we are given all the elements in an array already stored and we are just required to find the kth largest element. So basically what they mean by kth largest element is that the elements would be sorted in decreasing order rather than increasing order. So from there I'm required to find out that kth largest element. Basically this is the array which is being given to us. So here elements would be sorted in this manner. So as k is equal to 2, so this would be our answer. So this is here. And in this where we are, because they have also mentioned that not the k distinct element, right? So we are also required to keep a check that even if it is a duplicate element, still we can consider it. So here if we sort it, so it would be something like this. So here they want this 4. So here it is, the fourth element, which is 4 or itself. And thus our output is 4. Now, in all this scenario, means it is pretty much intuitive here that we are required to sort it, and after sorting, we are required to return the kth largest element. But now, in all these things also, before going ahead with solution, let us check for the time complex constraints. So the constraints are that the length could be till 10 raised to the power 4. So we could go ahead with n solution. Even if we are having n square solution, that would also work because 10 raised to power 8, that would be the thing. And each element could go till 10 raised to power 4. So each element going to 10 raised to power 4, that also works fine. Now comes the part that how we can go ahead with our solutions here. Now the first thing which comes to our mind is about sorting, and that also in descending order, right? So that is the pretty much first intuition which comes to our mind, and we just need to implement it. So that would be if we sort the elements, right? So what is the time complexity of sorting? It's always log of n, where n refers to number of elements, and when we do sorting, we then again need to combine them also. So that's why one n is also added. So overall complexity would be n log n, and we are sorting, and then we are required to find out the kth largest element, right? So we won't be using any extra space, right? We would be just reversing again. So that's why space complexity here would be order of 1 only, and this would be a time complexity. So this thing we could do in various manners, right? A second thing we could do is like we could use some data structure. We are just trying to reduce its time complexity, so that's why I'm now just trying that if we could use some data structure, then we could use some data structure where sorting is being done, right? And as here are duplicates also, right? So we can't use set or set, right? So we would be using a multi-set for that purpose. So when we use a multi-set, but again the time complexity would be same only, but here space complexity would increase. It will now become n, basically this n only, right? So let us try to reduce the time complexity further. We try, okay? So we could use a priority queue. If we will be using a priority queue, then our time complexity would be something like this. Why this log k would be there rather than log n? Because we will be using a priority queue of size k, means at one instance there would be only k elements in this particular priority queue, and we would be sorting this k elements only, right? And this thing we would be doing n times, so that's why n is at the front of this log k. So this is how we just reduce our time complexity from n log n to n log k. But here space complexity got increased to it, not n, but k. Basically from here it increased from 1 to k, but from here it decreased to k. So let us try to reduce this time complexity more further. We can reduce this time complexity more further by using some algorithm of sorting. So here we could use quick select sorting algorithm, and in that algorithm, our time complexity would be reduced to order of n in best case, but in worst case, it would be n square. But yeah, we are also getting order of n solution, so that's why we could consider it. And the space complexity here would be reduced to order of 1 only. So these are the 4 solutions which we could consider. Recently, I've just explained you with the time complexity and space complexity. Now, after this, I'll tell you about this code walkthrough of the same. So now, let us check that how we can code these solutions. So now this is the first, these first 2 solutions are just as it is intuitive, means basically brute force solution which comes to the mind. So how we can code the solution for just sorting? So the thing is that I'll take this for returning my answer for comparison purpose. Here I'm just sorting by using this sort, and I'm sorting in decreasing order. So I'll traverse my array till k elements so that I could find out my answer, because I need to find the kth largest element, and at the end I'll return the answer. So but in this we were traversing the array once, right? Now I'm thinking to reduce this without any means, so that I don't traverse the array. So here I just sorted and then just return this nums of k minus 1. Why I'm returning nums of k minus 1? Because the thing is that it is zero based indexing, right? So rather than k, I am required to return k minus 1th element. So that's why I'm returning this, and by this I would be directly going to that element. So this would be order of 1 operation only, right? And then this sorting is being there, right? So that's why somehow from the previous one, I just reduced the time complexity. Now comes the next part, that is we use some data structure. So here I have used the multi-set. Although the time complexity and space complexity have increased, the time complexity remains the same, but space complexity has been increased. But this gave us the way to priority queue. The thing is, what I'm doing here is that I'm inserting all the elements in my multi-set so that it could be sorted inside this. So this is that Nlogk operation, and then I'm traversing this particular multi-set, and whenever my count equals to element size minus k plus 1, because the elements which were sorted here, they were in increasing order. So that's why I would be required to go to that particular element, which is basically element dot size minus k, basically the one from the last plus 1, because it is already that zero indexing base, and I'll store that element and return as my answer. Here the space complexity is order of 1 because we are putting all the elements into our multi-set. Now comes the next part, that is our priority queue solution. So for this priority queue, what we are required here is, we will be required with a priority queue, as I'm doing this in C++. So by default the C++ do have a max heap in the priority queue. So I'm just required to insert all my numbers. So I've just inserted my all numbers by nums.begin to nums.end. This is like the standard way of inserting in it. But we could do the way we have inserted in that multi-set, like that also we could insert into priority queue by just doing that pq.push and traversing the whole array. Now here, that while my k remains greater than equals to 1, right? So till then I will be popping out, and when it becomes less than 1, basically it becomes 0. That is, I've reached my kth element. So at that time, I'll return whatsoever would be at the top of my priority queue. So by this, we are just storing k elements in my priority queue, and even the k largest elements in my priority queue, right? So that's why the space complexity is order of k, and the time complexity is Nlogk k for my priority queue. Now comes the part that how we can reduce the time complexity and space complexity more further. Basically, here I've used the standard the stl function of C++, but this is basically quicksort only, where this is the standard function being used in quicksort, that is nth element. By this, we are just required to put the beginning and the one which we are required to figure out, and then till the ending, and then we are sorting it in the decreasing manner, and then at the end we would be having our nums basically, which would be already sorted, and then we could directly return the k minus 1 element. So this is how we can do in the n in order of n time complexity and order of 1 space complexity, but at the worst case scenario it could reach n square also. That also we just need to keep in mind. So these were some of the solutions for doing this particular question. If you have any doubt about any of the solution, you could comment that down. So this was all. Thank you.